So today we're going to go over this compressor here. What do you do when how do you troubleshoot a compressor, I guess? And what do you do when you find that it's kind of, ugh. And over here we got, oh, it's tripped. There's a tripped compressor. What do you do? All right, well, hopefully we'll figure that out today. All right, so today what we're going to do is we're just going to go over, I made a list of 22 steps on figure out whether or not your compressor's kind of working right. We're going to go through the list, how to use the list. I'll attach the list below. Now again, I'm just going to mention this. Maybe I should mention this in all my videos, but do what your boss wants, do what your company does. Don't violate manufacturing practices, all that good stuff. If you get hurt, it's your fault. I'm just some dude on the internet, okay? Take the list and make it your own, okay? It's not this list from on high. It's not the 10 commandments given to the people. Like, I'm just a dude on the internet that does refrigeration and might say something that makes sense every once in a while. So if you have any input, put it below and all that good stuff. And I just hope this helps somebody realistically. So like I said, just a dude on the internet. Double check everything I said. This is definitely why I said make your own list. I've already added another thing, so now it's 23 things to do. But anyway, so we're going to go over the first couple. Turn off main power, turn off the compressor. Is your compressor isolated? And does your compressor have voltage pulling does your control voltage pull in the contactor? Okay? We're going to go through those super quick. Well, actually, and then contactor, ohm across, and look for pits. We'll do those right now. They're in a relatively specific order. So first off, I'm going to make sure power's off. So we're looking at this guy there, number 3. It's tripped. So now I'm just going to turn it all the way to off. Well, just no chance of it. Turn it on, none. No power. It's off right there. Now I know it says compressor 3 up there. That's actually wrong. I traced it out. It is wrong. Not okay. All right. Now, is power off? It seems to be off. Now we're also going to look at, there are 3 possible places. The breaker for the main power, the control toggle switch, and now at the actual rack. So that's rack D, I believe. Let me just verify. There's so many racks in this room here. D, yep, rack D. So what we're going to do is we're going to make our way over to the controller right here. Our Danfoss controller. We're going to hit home. And now we're going to use our arrow buttons. We're going to scroll down to rack D. I'm actually going to hit page down to scroll a little bit faster. We're going to go up to rack D. Right there is our suction group, which is 60 psi. Now that we're up here, we're going to go across the service. 1, 2, enter. Now that we're in service, we're going to look rack D compressor 1, 2, and 3. Manual off. So that's off in all 3 places. Okay, if you have your lockout tag out, if your company commands it, whatever OSHA standards, follow the law, all that good stuff, lock out and tag it out. Now we're also going to check, is it isolated? So you can see the discharge is isolated. You can look that the oil's isolated. That means that nothing is going into it currently. And the reason why that's significant, and we can look over here and see the suction is isolated. Why is that significant? Well, it's significant because if something if it's left unisolated, we're going to have oil more than likely that's built up in the unit. But in this case, that's not happening. Now, if we look down here, we can also see that the oil is drained out of it. I know that for a fact because I'm the one that drained the oil out of it. Okay? So now what I'm going to do is, I know that it's isolated. I know that there's no power to it. I'm actually going to unisolate the discharge and the suction. And then we're going to test that contactor and the safety. Now you can see the suction's all the way open. And the discharge all the way open. And now I'm going to just open up the oil enough to run just a little bit of oil into it in case. So the reason I'm doing this is we're going to test our contactor. We're going to test voltage. We're going to test all kinds of things. And on the off chance that it turns on, I don't want there to be any type of explosion. Like, you know what I'm getting at? Like, I know a guy who blew the head right off of a compressor. there will be no explosions, at least on my watch. And so what I'm doing here is I'm just going to open the oil line. I guess while we're doing it, I want there to be enough oil inside it so it can lubricate properly. I was actually working at another store where the liquid refrigerant washed out all the oil, and when the compressor was tried to be run, it actually screeched, made terrible sounds because there was actually a zero, like no oil in the compressor at all. So that's why I just try to make sure at least a little bit of oil gets to the compressor, especially if there's a chance of it running. And I know that I just pushed out all the oil because this rack just had a bunch of oil issues. But anyway, so now we're going to move on to this contactor here. Actually changing 4 and 5 around, so I already did it. So I think that you should look for your contactor for pits and whatnot, and check your ohms across it. Well, checking your ohms across it, so 4 and 5 are kind of together, but you should definitely check your contactor for pits before you start number 5. You want to make sure that that contactor has nothing wrong with it. So I always just check voltage from leg to leg to make sure this thing's as dead as a doornail, that there's no voltage coming in. Just on the off chance that this breaker's not working right, there's no voltage there. I check it, each one to this ground that's down there, and then I check them to each other. Just what I do. Now we're going to take out those screws and check for pits. So you can see I took the cover off. We're just going to look for pits and stuff, see how it's looking. And that doesn't look great. It doesn't look terrible, but it doesn't look great. Definitely looks old and worn. So now what we're going to actually do is we're going to check to make sure it pulls in, and we're going to check ohms across it. So the way that we're going to do that, and this is a double check that'll automatically check all of our safeties as well. So what we're going to do is we're going to turn on this control voltage, right? We still have it breakered off, and now we're going to go over to the controller over here, and we're going to manually turn on that compressor. And what that will tell us is that'll actually tell us, you know, do all of our safeties work? Or at least, can it give the green light for the compressor to turn on? So we're manual it on, compressor number 3. It's open, so if there is anything that happens, should be good to go. And now we're going to take a look. Is the contactor pulled in? You look, that contactor's pulled in. So now we can automatically phase out our low pressure safety, our oil safety, and our high pressure safety. We can phase them all out because we know that, okay, voltage is going through that daisy chain and activating this contactor here. You can see I'm ohming across it. I get 1 ohm. Now if you get open line, that is not good. Or if you get a high amount, 1 ohm I'm not even thrilled with. Like, it's not terrible. Usually brand new ones give you 0. Sometimes they give you 1, but typically they give you 0. So there is a little bit of pitting. But what I'm looking for here is, let's say I got an open line across one side. That's going to cause this to trip, because on the other two, you're going to be pulling like, 30, you're going to be pulling significantly more amps on the other 2 lines of power to try to make that work. So I know, okay, that seems to be all right. So I'm going to turn off my control voltage. See that pop right out, and now I'm also going to turn it off at the controller over here. All right, so as far as I can tell, the contactor is not what caused it to trip. All right, so now we're going to take a look at this right here. So what we're going to do is we're going to touch these leads to leg to leg. So we're going to look at this. You can see. Let's see if I can get a video of it. Kind of hard to do. So you can see that. We're working at the bottom side. Oh, I should have went to my list. I'll go to my list after. We're going to the bottom side of the contactor right here. So leg to leg. You see that? We're getting 2. Right? And now we're going to shift over. Those 2 leg to legs. I'm getting 2. And now we're going to do these 2 leg to legs over there. Kind of hard to do with one hand. 2. And now what we're going to do is we're going to test each leg to ground also. so kind of hard to do, but you can see, testing that leg right there. I'm testing to that little grounding wire right there. And you can see, you can't really see because it's super hard to do, open line. So I'm going to do that to all three. So we're past all three on the contactor. So now we're going to move to the compressor head. I'm going to go to the list and we're going to go through that. So we ohmed out the legs of the compressor at the contactor. Why did we do that? Because some compressors, such as Compressors, they actually have like a whole safety pack, and you can actually catch it by ohming it out at the contactor. I actually did skip a step, which if there is a head fan, ohm it out, because sometimes the head fan will actually be piggybacked off of the main power and cause it to trip. So number 6, check if there's a head fan on the auxiliary. There is no head fan on the auxiliary, so we didn't need to do that. So we kind of skipped number 6 because it wasn't applicable in our system. So ohm out the contactor, ohmed at the contactor. That's just what we did. We ohmed out the legs of the compressor to each other and then ohmed them out the ground. So that tells us if there was a protection pack. I'm going to link my video below where I did an overload for a Bitzer compressor where that came into play and you can catch it. And that's why I include it in my list. Now we're going to actually ohm out at the compressor. And if you can remove the leads, a lot of the compressors I work on are so old that the bolts are so stripped out that we can't remove the leads, but I'm still going to test it at the compressor just because it's good practice, because sometimes you might actually get voltage to ground, or you might actually get a bad like open line to one another. But in reality, it's because your actual wires leading to your compressor actually has a break in your wire. So that's why we do both. And if you remove the leads, it's better, because if you're getting voltage to ground, if one of your leads to your compressor is grounded, right, then when you actually go to your compressor and you test at your compressor right there, right, you're still going to get that grounded, because it's still grounded because it's connected to your leads. So if you can remove your leads, it is good practice to do that. So you can see that's inside the head of the compressor, the electrical box. So you see those 3 giant terminal blocks. I don't know if I'm going to be able to record this just because it's there's no way I can really hold the camera, but we're going to have to text an ohm to one another, as well as ohms to ground, resistance to ground, and if possible we should remove those leads out of there if the bolts aren't stripped. So I have no idea right now if you can hear me or not, but we'll just try it. So right now I'm testing voltage to ground, make sure there's no voltage, and now switching it to ohms. I hope you guys can hear me. I don't know, maybe I'll have to record over. We'll test ohming to one another, ohming to one another, ohming to one another, and now I'm going to ohm the ground. It's over here, the ground, right there, or you can just pick a piece of steel, open line, open line, open line. So electrically speaking, this seems to be just fine. I'm going to close it up and move on to the next test. As a side note here, I just wanted to show you, this compressor has a head fan right there. You can see them over there. They have some head fans. It seems like the way these head fans are run is, you can see it seems like they're actually just running out of the bottom of the compressor with fuses. So what you would do is you would ohm across the head fan, and you would check the ground if your compressor had it, because especially if it doesn't have those fuses, it can blow, it can trip that breaker as well if it grounds out. I just wanted to include that just to make this video more comprehensive. Is our connection tight? Is the compressor filled with oil? If so, empty it, isolate the suction, and take the suction side pressure. So I think we'll do that right now. First off, all the connections tight. There's our one, tight, 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 tight. And we can go in the head of the compressor. I already checked them, saw that they were tight in the heads of the compressor. No loose connections as far as that we can see. We know the contactor goes in and out. All you do is just give a decent pull on them, and everywhere it's connected. In the electrical box, on the contactor, on there. Now I'm hesitant to pull up there because I'm not gonna touch the live wires. So don't touch live wires. Make it home to your wife and kids. So as we went over earlier, there's no oil in there. Well, now it looks like it has oil. So I'm gonna close that oil line because I now know that there's enough oil for it to run is what my goal was. That's actually step number something. So we're going to close this. It has more than enough oil in it now. It shouldn't be overfilled though. It was only open for 5 minutes. And so now what we're going to do, we're going to hook up our gauges onto the suction. We're going to close the discharge. Alright, so you can see that it's hooked up to the suction. Suction's closed, right? And the oil's closed, and the only thing that's open is the discharge. Now why? Why am I doing that? Well, these compressors have reed valves in there and head gaskets and all kinds of things that keep the refrigerant from going back, and they could be possibly, shifted. The piston cylinders could be, worn, and now they're, there's a gap in the piston cylinders. It's allowing refrigerant through. All kinds of things that could cause that. So if you have discharge flowing into the compressor, that is a no-go. That means that there's something internally wrong with your compressor. So at this point, if I were to find discharge flowing into my compressor, what I would need to do is I would then need to take off the heads of the compressor and evaluate it further if my customer wants me to. Okay, if my customer would say, hey, this compressor's 30 years old, just get us a new one, please. Then I would, okay, let's get you a new compressor. But in this case, it passed the test. So now we're going to move on to the next one. Does it have floodback? Let's take a look. Alright, so now we're going to check for floodback. This is an easy one. This is a medium temp rack. So typically speaking, on a medium temp rack, if there's no frost, there's no floodback. Only on medium temps. Okay, and you can feel and try to see and whatnot. If anything feels too excessively cold, it could be flooding back. Another way of checking is listen for the gurgling. Do you hear any of the compressors going, making some type of noise or obsessive vibration? Like if you see any of them just like shaking the rack, those are symptoms of floodback. Those compressors are trying to deal with the floodback desperately, and it's not, it's just not doing it. But I just wanted to show this. This is a more scientific way to check for floodback, which is I have my little temperature probe from my clamp up in the armor flex, right? I have this hooked up to the suction right there. So I know that for 404A at 72 psi, the coil is going to be 32. Now if I go to my superheat, it says I have 36 degrees of superheat and the temperature is 68 degrees, right? So the evap is 33, the temperature is 68, gives me 35 degrees of superheat, which is heating up the refrigerant before I get to the rack. The rule of thumb is typically around 20, and typically compressors will have a maximum and minimum that they're allowed to have going into it. But so as far as we could possibly have an overheating issue, and that refrigerant that is too warm is coming back to these compressors, but as far as floodback, it doesn't seem like we have floodback here. And now if you really wanted to be all in about this, you could check this for every single circuit on the rack. You could even manually turn everything on. And you could also, what you could do is you could put on, if this was a low temperature circuit, you could put on hot gas defrost. And what that would do is that would make sure that this valve is closing correctly, because sometimes your hot gas defrost will actually come right back in and just go into the rack. So if you were really having compressor like explosion issues at a store, you could go through, check on every single circuit for floodback, and then you could check on every single circuit to make sure that this suction service valve or an EPR valve is holding back the hot gas when it defrosts the case. So now we're up to 24. I added another point right here. Are any of the circuits on the suction side of the system hot, or any of the compressors on the suction side hot? So we'll do that now. So what we're going to do is we're just going to touch. Is it hot? Nope, it's cold. Touch. Is it hot? Nope, it's cold. Touch. Is it hot? Nope, it's cold. Hot? Nope, nope, nope. And this is just making sure there's no discharge being fed backwards into the system. Now, on a medium temp, it's very unlikely, but still possible. So let's say even if this compressor here is just dumping discharge in, it could come through and it can cause this compressor to trip. So that checks out just fine. Now we're up to 25 steps. I added one more. So what we're going to do is we're going to check 16 and 17, which is before starting. Make sure there's enough oil to start. And before starting, get the compressor information. We want to know what we're looking at. And then we're going to carefully start the compressor. Do not stand in front or near the compressor or the contactor. We'll do that now. So we're going to go look. Now, some people, and leave me in the comments what you do below, maybe they open up the compressor. We are taught, so there's just enough oil to run it. And so we are taught to actually, like, we don't want to necessarily open the compressor because that's very invasive. We can get things into the system that aren't okay. And so from my experience, opening a compressor without probable cause can be more damaging than just, you know, starting it up. But anyway, so we're gonna look at this. It might be hard to hear me, but we're gonna look at that tag right there. And we're gonna look up the compressor now. We go into the Copeland mobile app here. We type in, you can see at the top right there, I have to do it with pictures because Copeland Mobile doesn't do it great. So we put in at the top the 4DE3 2000 TSK, okay? And then we get a list of options below. Now, unfortunately, this isn't going to be perfect. I wish it was a perfect example, but like I say, perfect is the enemy of the good, and I at least have the example to give. So our system has been converted to 404A. So this compressor is so old that there's only data for R22. We're still just going to use it as just some type of frame of reference. So if we go up here, we have application, medium temperature, right? That's what we're dealing with, 460 volts. That's what we're dealing with. And unfortunately, the refrigerant's R22. In reality, our refrigerant is 404A. They are much different, but you got to do what you got to do. Work on the system you got in front of you. So after you select your compressor of choice and the application that it's using for, we're going to go to electrical and we're going to read the electrical data. So if we go to electrical, under summary and winding resistance, we're going to see these couple things. So under summary, we're going to get this maximum continuous amperage and a run load amperage. And so for me, I pay most attention to maximum continuous amps. So that is the maximum amount of amperage that this system can run continuously without drawing damage. So for the most part, as long as I'm not going over that as a general rule, it'll probably be okay. And we're also going to look at the winding resistance right here, which is line to line should be 0.174. So as you could probably tell, my voltmeter isn't capable of reading that fine of a measurement. So I think we got about 1 to 2 to each one. We're just going to have to assume that that's okay. It might be worth me investing into a better voltmeter. Now from this mainstream, we're now going to hit on performance and look at performance. Now in performance, you can see we have case number 1 and case number 2. And in this case, we got an evap temperature of 20. We're currently targeting 23. So we're just going to use the evap of 20 as an example. And so that should be giving us around 45.8 amps. So again, it's of a different kind of refrigerant. So we're not entirely sure what that's going to mean for us. But so what I did was I went to this Emerson PT Pro app, which is Pressure Temperature Pro. And I just wanted to see 60 psi of 404A is 10 degrees colder than 60 psi of R22. So this is dealing with a higher pressure, but the densities are different. So we'll just see. So basically what I'm going to look at is I want to see for our normal condition, I want to see that the amps are not over this 46 value, and that it's not drawing like 80 or 50 or 60 or something like that. That might be indicative to me that there's something wrong. All I have to do is open her up, is turn her on. Now I'm going to show you how they do that. Do not stand near or close to the compressor or the contactor. You want a rough night, have a contactor explode on you. It screws you up for a little while, okay? Stay away from them. And then we're going to take, listen, how does the compressor sound? Take an amp draw. How does it compare to the specs that we just looked up in step number 17? And does it hold the compressor efficiency test? We're going to do those following things right now. Alright, so now what I'm going to do is I'm going to turn this on. Well, I'm going to go make sure that it's off at the controller, because I don't want to be near it when I turn it on. I'm actually going to set everything up, and I'm going to turn it on at the controller. Some people turn it on at the toggle switch because it gives them greater control. It's manually off, which is a perfectly reasonable way to do it. And if it was the last compressor on it, I might do that, but I don't want to be anywhere near the toggle switch. So I'm going to turn this on. I'm going to close this in case of an explosion of some sort. I'm going to turn this on, and now we're going to walk over here, and this is where I feel safe doing it. Do what feels safe to you. I'm going to manually it on from over here, and we'll see what happens. So now here, manual on. Let's see. Hopefully nothing happens. So I didn't hear any big booms or nothing. So more than likely it's all right. So just like proceed with caution. Listen. So that's pulled in. Okay. Is it making any bad noise? No, not really. It's rattling a little bit, but if you look, got screws out. Maybe the rattling's what caused it. I don't know. Not making anything terrible. All right, now let's pull some amperages and see. Now again, it's going to be hard because the refrigerant really isn't the right refrigerant, but we'll see what we get. 23, 26. 22. Okay. Now I'm going to look at my gauges and see what the pressure is there. So a run line amps is about 29. So currently it's at 51 psi. So this is around where it's going to be running. So those are okay, right? So the maximum continuous is 46. The run load amp is 29. So this is at a lower pressure than it would be normally running at. And according to this, it's running 25. That is perfectly 21, 25. That's weird. 21, 6. So it seems pretty reasonable right now. 21. Let me just really try to get in there. I think I'm screwing myself up on this thing. Yeah, I am. 23. 20. You can see that no one line is over amping or running too bad. Like there's not one. There's a little bit of variance in there that I'm a little bit uncomfortable with, but I don't think it's enough to do anything. So now we're just going to check, is it hot? Hot discharge. We're going to come over here. Do we have a cool suction? Yeah. Seems like a cool suction. So now we're going to run I think the next step is a compressor efficiency test. The last one is the compressor efficiency test, 22. We'll go take a look at that. So compressor efficiency test. So I don't know if this is written anywhere, okay? I've only found literature on this from Emerson. Not Emerson, Bitzer, from Bitzer. Bitzer knows about this stuff. Bitzer does this on its compressors. I don't know if you're supposed to do it on a Copeland or an Emerson or whatever. I don't know. Anyway, it's like a tribal knowledge of the people and the group of technicians that I talk to. This is what we do on the compressors, and I'll just show it to you quick. Hey, if you know, like, this is not good stuff, don't do this or something, comment below. Let me know. I don't think it is. I think this is perfectly reasonable to do because it makes sense to me, but we'll just do it now. So I'm going to hook up to the suction and we'll move forward. What I did was I closed up the suction service valve and I hooked up. So there's two ways I go about doing this. I guess there's a couple ways. So number one, what I do is, so we close the suction, we hook up our gauges, and we're going to see if it can pull itself into a vacuum. Okay? And now from my understanding, before you start saying, oh, they should never run in a vacuum, so first off, this is only for semi-hermetics. Only for semi-hermetics. Only for semi-hermetics. Only for semi-hermetics, okay? Like, let me just repeat that enough. You can't do this with a scroll compressor, okay? They can't really do this. You can't. So what you got to do is you can just have one scroll run on the rack, and you can just see, does it, pull down the rack? Does it maintain a pressure, or something? In this case, for this one, we saw that it did maintain 50, absolutely fine on the rack. So I have a lot of confidence in it. But what we're going to do is, so the breaker's on. Actually, we can keep the toggle off because I don't want the controller communicating to it. Actually, all we're going to do is we're going to take an insulated screwdriver, and you can do it one of two ways. One, if you don't feel safe with insulated screwdriver, you can just turn down this as low as it can go, and you can see like how low is it capable of pulling itself. So what you can do is you can turn this low pressure control down to 0 and see if it's capable of pulling down to 0, or you can just like tap this in once. 1, 2, 3, 4, 5. Insulated. Okay, that's a lot of voltage there. Okay, just tap it once or twice, come over and see what happens. So you can see that it pulls itself down pretty good, and then it goes up pretty quick. So we can see that it can pull itself negative 13. It's coming right down though. I'm not thrilled about that, but I would say this compressor's on its way out for sure. Could maybe use some love, but it definitely doesn't seem to be worth shutting down on the rack. Right, if we go through this list really quick, just like we did, if we look at the contactor, not the greatest contactor. I think I'm going to replace it, but not the issue. The safeties, just by the fact that the contactor pulled in, eliminates that the safeties are what's causing the compressor to not turn on or whatever. So this is just a general list. So for instance, if you out there came across a compressor that wasn't turning on, how do you just approach it? Is the head fan out? Well, there is no head fan, so that doesn't matter, right? Ohmed out at the contactor, that checked out. Ohmed out at the compressor, that checked out. All the connections are tight. Is the compressor filled with oil? This is important because if you turn it on when it's filled with oil, it can damage the compressor. It was not, so didn't need to worry about that. Number 13, we isolated the suction. Did it blow by the discharge? It didn't at all. So was there floodback? I didn't see any. Any of the circuits hot? Nope, no circuits were hot. Before making sure it had enough oil, I did. Before starting the compressor, Get the compressor information. We went through that. We started the compressor. How'd the compressor sound? It sounded fine. We took an amp draw. The amp draw was fine. Now the amp draw, there was like a half, when I readjusted my amp clamp correctly, there's about a half amp of variance between the middle one and the other ones. I think they all should be just pretty close to one another. So that's probably a sign that there's something, it's on its way out. But you can have the discussion with your customer. You could get maybe another year out of this compressor, or do you want to replace it now? Now, the discharge was hot. The suction was cold. That was also correct. And this number 22, which was the efficiency test, it was capable of pulling itself into a vacuum. It almost pulled itself out of the vacuum immediately, which I'm not thrilled with. That might mean some of the seals inside aren't the best. Maybe the O-rings around the pistons are going or whatever, but it was capable of pulling itself into a vacuum as well as holding the system at 50 psi. I would say that this compressor is fine. I don't know why it tripped. I think it might have to do with the vibration, or maybe one of the cases when it goes in and out of defrost, it causes a liquid slugging that would cause it to trip. That's very possible. So if a case is overfed when it goes in the defrost, okay, that liquid that comes back can cause a slugging. Also, we did have a rack disaster a little bit ago over here with some oil failures. Maybe like it shut down and then filled up with oil. I'm not entirely sure, if I'm honest. But as of right now, the compressor itself seems to be in working order. And now we can go and figure out, okay, why did it trip to begin with? But that's a whole nother thing. This is mainly just a troubleshooting step. Now, I want to mention these 23 through 24 steps. These are steps that you take if you believe the compressor has probable cause to open it. For instance, if the compressor sounds like a bag of marbles, more than likely you're just going to replace it, but you could open it and look and see, does the piston move freely? Take the head off the compressor, look at the reeds. Is there black goop? Pieces of steel, scored piston wall. This will tell you, does it look like corrosion? This will tell you a story on, was it liquid slugging? Was it corrosion? Why exactly did the compressor fail? This is useful for that. Now, another one up here would be if you isolate the compressor suction, right, and then it just blows back into the discharge, that's another reason to open up the compressor and take a look on the inside and say, hey, I'm going to take a look on the inside and see. Right now, those ones are tests that if you fail, the next step is, with your customer's permission, either you're going to take a look at the inside or you're just going to replace the compressor depending on what they want. Like, for instance, if your scroll compressor sounds like a bag of marbles, you just got to replace it. There's nothing you can do. Also, remember the efficiency test on your scroll. You can't pull itself into a vacuum, so maybe just shut off the other compressors and let it run and see if it can do its thing. Hot discharge, cold suction, that's good enough for me, as well as the amp draw and the other things to kind of say, all right, that scroll seems to be working okay. Now, these ones in the beginning, the ohming out your compressor, ohmed at the compressor, remove these right here. If it fails, you're ohming at the compressor. Okay, so if it fails, ohming the legs of the compressor to itself or ohming to ground. If it fails, you're done. There's nothing you can do. Electrically, it's compromised. Shut it down. Don't start it up. Don't bother looking inside. Electrically, it's failed. There's nothing you can do. They have to replace the windings. Nothing you can do. Okay? But anyway, I hope that gives you kind of a decent guide. I will link this guide below. And I hope this came out okay. I know it might be a bit rough, but perfect is the enemy of the good. So I just want to try to get this out there, just do the best I can. And again, I'm not a perfect tech. I'm just a dude who happens to take videos during his lunches at work. Please comment below. Am I doing things unsafely? Am I not doing things right? Whatever you think, please let me know, because I want to learn and grow and develop, and I'm hoping to make the industry safer and better for other technicians. I hope you learn a thing or two about a thing or two, and that's how you do it.